Hello and welcome to tutorial 203, and a Gold Pass member asked me the question, how would you go about showing the volume ratio on RadarScreen? So first of all, let's just have a quick look at the volume ratio indicator, the standard TradeStation volume ratio indicator, and you can see it here, and the guts of the calculation occur here. Now the problem with this is that UpTicks and DownTicks work for charts but not for RadarScreen. In fact, if we just right click on that, you'll see that we can go to all the relevant volume words for TradeStation, and you'll see for RadarScreen that, for example, for stock symbols, the UpTicks give you total volume and the DownTicks return 0, whereas, for example, on a chart, you'll see UpTicks returns the shares traded on UpTicks, and DownTicks the shares traded on DownTicks. So he wondered, the Gold Pass member, how you would go about showing volume ratio in RadarScreen. So I've got a couple of ideas of things that you can do here. You can see we've got a RadarScreen here. I've created an indicator not dissimilar from the standard indicator, and you can see that clearly those ratios don't work. We're just getting 100, 100, 100. But what I've also done is created a program that is applied to a chart, and then the chart sends the value to RadarScreen. Now obviously this has the disadvantage that you need to have a chart open at the same time as the values for RadarScreen. If you've got several hundred values in RadarScreen, this is probably a little bit onerous, but you'll just see if we look at, for example, the E-mini, and the sender is applied to this chart, and then those values are being returned or sent over here, so that we've got the values on RadarScreen. So let me first of all just run through how the programs do that. So we've got, as I say, two programs. We've got the sender and we've got the receiver. So let's have a look at the sender. And essentially what we're doing is creating a global dictionary and a vector. And we create the global dictionary using this syntax because we want the global dictionary to be shared between the chart and RadarScreen. We're setting up a vector. And then we're saying if this is a minute chart, minute or tick in fact, but this program's designed for minute charts, then we can calculate the values using the standard formula, which is total ticks, UpTicks plus DownTicks. Bear in mind this is being applied to a chart, not to RadarScreen. And then having calculated the values, we store them in the vector. So if the vector is empty, we can store them using pushback. And once the vector has got values in it, we're going to put them in the position 0 and 1. Having done that, we then store the vector in the global dictionary, and we do that with the key being set to get symbol name. So the key for this value is going to be the symbol name, and we're going to store in that as the value the ratio vector. Now bear in mind there's nothing here to make sure that the receiving and the sending charts have the same interval, so that's something that you could potentially add to the program to make it more useful. And then we plot the values. So that's the sending indicator. What we've also got is a receiving indicator. And what that does, again, looking just down into the one statement, we create or initialize the global dictionary. Then we have a couple of item changed events. First one being item added, and then another one being item changed. And then we create a new vector which we've called received ratio vector. So what happens if either of these events are fired, in other words item added or item changed, then we call this update plot method in both cases. And in the update plot method, what we do is we say, we're looking at this for each row applied to RadarScreen, we say if args key is get symbol name, in other words there is something in the dictionary that has just fired, the events just occurred for the symbol that we're actually plotting in our RadarScreen. Then we say if it contains the symbol name is not false, then we're going to say received ratio vector equals the global dictionary items, the name of the symbol as type vector. So we're now getting the vector that we've just sent from the sending chart into the receiving chart, and then we're plotting the two values in the vector. And I've just added some extra checks just to make sure there is actually values in those. There are enough values to be able to plot. So that essentially is the program. That makes sense to you. So that's one way of doing this. As I say, the big disadvantage is you have to have a sending chart, which is a little bit of a fiddle. Now, the other way is using a price series provider. Now, if you look at these values carefully, you'll notice that they're not totally synced with each other because the changes in the data do not occur exactly at the same time as the PSP. That's one of the disadvantages. But this program is mainly designed for RadarScreen. But if you do apply it to chart, what you'll find sometimes is because the chart data and the PSP are not synchronized together, you will see that you'll get some little errors where, for example, the PSP finished a millisecond before the end of chart or vice versa, and that can cause discrepancies when comparing values calculated using the standard TradeStation indicator with this indicator. But let's just look at it in terms of the RadarScreen, and I'll just run through the program. So a little bit more complicated than the other programs. Namespaces I put here: elsystem.collections and tsdata.marketdata. See the inputs there. So let's go first of all to the one statement, and this is where we're creating the price series provider. If you're not familiar with creating price series provider, the easiest thing is to go into the toolbox, double click on price series provider, put in the data that you think is appropriate, and having done that, go to the designer generated code, copy the code from there into your program. But I've already created it. You'll see some things here. We're looking at data chart type bars, so it's a bar chart rather than volume chart. We're using the minute chart. The value of the bar interval, that is going to be taken from the RadarScreen data range type bars. Put in the range bars 5 times average length because we need to have a sufficient quantity to be able to calculate accurate values, particularly when we're creating the exponential moving average. We're including volume, we're not including ticks. We're using real time, and then not strictly necessary here, but I just like to keep this code that we can essentially use time zone of the chart when this is applied to chart. The name PSP, load true, and then we've got an update event, the standard PSP update event. So that is what we set up in the one statement. We now can look at the updated event. So when the event is updated, if it is a chart, then we're going to do something slightly different from if it is RadarScreen. And the reason that I've done this is simply to try and remove one of the problems that can be caused by the synchronization. Unfortunately, this creates another problem, but the way I did it is just to check that the volume was greater than the volume the previous time the program worked. Otherwise, it implies that either the bar has ended normally or the PSP has ended just a little bit before the end of the bar. And so this will smooth out some problems, or at least it's my attempt to do so. But if it is RadarScreen, in other words, application type equals 2, then we set these two variables here, PSP vol up and PSP vol down, to be the PSP.volume up 0 square brackets PSP.volume down. And if you look in the inputs, you'll see that I have made these both intrabar variables. Put in a little bit of debugging type print statements, which are not necessary for the running of the program. And then what I do, having done that check above, I just set the PSP vol up last update equals PSP.volume up as type double, and similarly for the PSP vol down last update equals PSP.volume down. So that is where the updates occur. Now we need to calculate the values. Now for a chart, what we could do is just use the UpTicks and DownTicks like we did before, and we're doing that here just by way of example, and we're plotting those values in plot 1 and plot 2. You'll see though, if we go back to RadarScreen, that we don't get anything plotted there, and again that's because of the problem I've just described. But what we're going to do now is calculate the values using the PSP. So as you will have just seen up here in the PSP updated event, we're setting the PSP vol up and PSP vol down to be equal to the PSP volume up values. So in our calculation, we again do the standard calculation, but just using these values rather than using the upticks or downticks. We're doing that if this is a chart. If it is RadarScreen, we're just going to use PSP volume up and PSP volume down, as you might expect in a more simplified program. Then to find out the exponential moving average, we can use X average. What I've also done though is just another way of doing this is to just go backwards each time and recalculate the moving average. So the X average, that's sort of going backwards. It's using previous values. This way of doing it is actually going back and redoing the calculation. Again, I don't think this is necessarily any advantage or one or the other, but I just wanted to include that code because it might be useful for you. And then we plot the bars, and what I've done is made the color slightly different if they're historic bars using the Get App Info AI real-time calc. I'm doing them as white, otherwise I'm doing them as yellow. And we're also plotting plot 6, and that is the exponential moving average calculated using the other way that I just spoke about. And then again, we've got some print statements, debugging information, which we can just comment out if we don't want to. And this here bar stat last tick was just something I was using when I was debugging. So hopefully you might find this useful. You could probably, if you wanted to, type this program in again, which is probably quite a good learning experience. If however you'd rather download the programs, I will make them available. And if you like this sort of stuff, please subscribe to the markplex YouTube channel and also the email list, and visit markplex, markplex.com. So thank you very much.